Let's
Okay.
begin. Today, let me say, the last time we talked about hypothesis testing. We talked about hypothesis testing um, generally, and so we tested one population. And when we say we tested one population, let us say that we have workers. We say the hypothesis we test is that it takes 15 minutes to complete a particular job on the average. So we test that hypothesis, but we're looking at the entire population. Now, what if we were testing the population, the hypothesis, that the unionized workers, and we're comparing them with non-unionized workers. We state a hypothesis that the unionized workers complete the assignment in 15 minutes, while the non-union workers complete the assignment in average of 12 minutes. So now we are comparing two populations. From within the same population, we're comparing two. So that is called a hypothesis for two populations, as opposed to hypothesis for one population. So we make a comparison. All right. So the last time we did a hypothesis test for one population. Okay. Now today we're going to do a hypothesis test for two populations. Now before I go into that, I give a class assignment. Okay, I'm going to pull up that class assignment to provide some guidance as to how students can complete the assignments or what they need to do to complete the assignment. Going to share screen. Okay, we share screen. In order to do a hypothesis test for two populations, you need to have two subpopulations. And I'm going to give you an example. This is an example of a problem that we do a hypothesis test for two populations. Now, this is part of your homework assignment. We are looking at claims for damaged goods. We're looking at claims for damaged goods. And you see here, for example, that in this manufacturing plant, which is part of your homework assignment, there are two shifts. There is a day shift and there's a night shift. Okay, there's a day shift and there is a night shift. Now, you have on the left column here the amount of claim of damage. And you have next to it the shifts. You have the shifts, and the shifts are day shift and night shift, and they are coded. They are coded 1 for day shift and 2 for night shift. The first thing you do is to sort the data, okay, by shift. So you can see I paint the data. Then I sort by by shift. I'm going to sort by shift. And when I sort by shift, what do you get? See, all the ones come first, and then all the twos come next. And so now you can calculate the average claim by shift. Okay. Shift 1. Shift 2. Okay. And you can say average. This is shift. So that's average. And so you calculate average for shift 1 equals average all the way down. So the average for shift 1 is 274, and average for shift 2 goes from 77 to 111. Or can you say it's 368? Am I correct?
268.
All right, that's what I like to see. 77 to 111. What did I get here? 77.
Supposed to be for cell A. For A, not for B.
Oh, okay. Let's see. 77. B111. I don't see why.
In the formula, you have B77, supposed to be A.
Oh, yeah. Sorry. Thank you very much. So it's obvious you are following what's going on and that you have done your work. Okay. And so you calculate the standard deviation. Okay. You calculate the standard deviation. And so it was as T standard, sample standard deviation, standard.s, STDEV.s. Again, go to right. Maybe A. All right. So in order to compare, in order to do any hypothesis test, as you know very well, you must have a mean, you must have a standard deviation, and the sample size is n, and here you have 75. Okay, and then on this side you have 77 to 111 is 44. 45. Okay. All right. So you have what you need. So you must have a mean, you must have a standard deviation, and you must have a sample size. So we write those down. Okay. The average, one shift two, I'm going to write it down, 274.16. And 268.77, and standard deviation is 54.76, and the other one is 50.49, and sample size is 76 or 75, and this is 35. All right. So now our objective in solving this problem is to ask ourselves the question, is there truly a significant difference between shift one and shift two with regard to the amount of claims? For example, is there a significant difference between the day shift and the night shift with regard to amount of money that is claimed for damaged goods? Okay, and you can do that test of hypothesis for the two locations, Brooklyn or Queens, because you can ask the question theoretically as a manager whether differences in the amount of claims are based on shifts. Maybe the night shift people, they are sleepy, and so that's why their goods are more damaged. Or is it that the differences in the amount of claims are really based on location, and maybe the Brooklyn guys do not do a job as good as the Queens guys for some reason, or there are more claims due to damages from Queens than Brooklyn. It could be that the machines in Queens are older, all right? Or it could be that the workers in Queens are less experienced, or if they're more experienced, then there's less damage on their side. And so we have those numbers. So how do we then proceed with regard to test of hypothesis? Okay, so we do the normal thing that we do in test of hypothesis. We do the normal thing in test of hypothesis. So we state a null hypothesis. We state a null hypothesis. Okay? That's what we call it, the null hypothesis. And the null hypothesis is that mu1 is equal to mu2, which is to say that the average for location one is the same thing as the average for, the average for population one is the same thing as the average for population two. So there is no significant difference between population one and population two. And here population one is night shift and population two is day shift, whatever it is. Or you can make it the other way around. Population one is day shift and population two is night shift. So there is no significant difference between the two shifts. Okay? There's no significant difference. There's no significant difference between the two shifts. The alternate hypothesis will be that there is a significant difference between the two shifts by simply saying that the average claim between the two shifts is not the same, it's not equal, okay? And so you say there is a significant difference. All right? As usual, of course, you have stated the null and the alternate hypothesis. Okay? As usual, you state a level of significance. Let us say that the level of significance is 0.01. If you look up the table of normal distribution, the critical Z for 0.01, Z star is equal to 2.33. Okay, I know what they are, so I'm writing them down. And so please, based on previous lectures, look up whether this is correct. Okay, it's 2.33. And so now we'll not do a calculated Z. We'll not do a calculated Z. We calculate Z. Now, as you know, we calculate Z. We calculated Z, which is to tell us how far away is our sample mean from the hypothesized mean. Because when you say that mu1 is equal to mu2, you're saying that mu1 minus mu2 is equal to 0. Okay? You're saying that mu1 minus mu2 is equal to 0, which is to say that the null hypothesis actually is that mu1 minus mu2 is equal to 0. If the two are equal, then when you subtract one from the other, you get a 0. Conversely, the alternate hypothesis says that mu1 minus mu2 is not equal to 0. Okay? Conversely, you're saying that mu1 minus mu2 is not equal to 0. This is what the alternate hypothesis implies. Yeah, the alternate hypothesis is that mu1 minus mu2 is not equal to 0 if they're not equal. And so we calculate Z, and Z is x1 bar minus x2 bar minus 0 divided by S1 squared over N1 plus the standard deviation for the second population squared over N2. That is the formula. And the decision rule is the same thing. If Z is greater than Z star, then we reject the null hypothesis that there is no significant difference between the two populations. If Z is greater than Z star, okay, so let us see what we have, okay? We have that Z is then 274.16, 274. Point 16 minus 268.77 divided by the square root 54.76 over 75. Plus 50.49 over 45. All right. And so Z is equal to what? Okay. 274.16 minus 268.77 is 5.39. So we have 5.39. The square root 4.76 times 54.76 is 2998 over 75, 39.98. Plus 50.49 squared over 45, 56.65. is equal It's 9.83. So 5.39 divided by 9.83. Okay, Dwight, what did you get?
Let's see, I got 1 second. .5.
Okay, 5.39. 5.39 over 9.83. Is that correct? We get
Yeah.
0.5483. Okay. So we get 0.548.
4.8.
Okay. And so now we have a decision rule. We have a decision rule. And what is that decision rule? If Z is greater than or equal to Z star, that means we reject the null hypothesis. Am I correct?
Correct.
Okay.
Because the claims are too close.
And so once we reject the null hypothesis, we are saying that there is a significant difference. No. Yes. If we reject the null hypothesis, we're saying there's a significant difference between day shift and night shift. But if Z is less than Z star, that means we cannot reject the null hypothesis. So by not rejecting the null hypothesis, we say there is no significant difference between day shift and night shift in this particular problem. And you can follow that method. You can follow this method to resolve all the problems that we have on this week. Did you follow me?
Yes, Professor.
Okay. So that concludes the guidance and the lecture. You can now use the method that we have to solve the other problems. You get it?
Got it.
All right.
Yeah,
So any
I
other? Go
submitted.
ahead.
Sorry, I submitted this one already.
Okay. All right. Fine and good. This is for the
Okay.
benefit of those who have issues. So next week we will now go into regression analysis and the rest of the class. All right.
Okay.
Okay then. Thanks for coming.
All right. Thank you, Professor.
Have a nice evening.
All right.